Have you ever watched a coin flip? Or rolled a dice and thought, life is random, chaotic, unpredictable? Most of us take it for granted that the universe, especially at the smallest scales, is ruled by chance. Quantum mechanics, we're told, is fundamentally random. Particles appear, disappear, and behave in ways that seem utterly unpredictable. But what if all of this is not what it seems? What if randomness is an illusion? What if there's a hidden order behind the chaos, a pattern that we've been blind to? Let's start small, with something simple you experience every day. Imagine turning on a light switch. Electrons flow, the filament heats, the room illuminates. It seems ordinary, predictable, safe, yet at the microscopic level, each electron is a tiny traveler, guided by rules so strange that even the brightest minds have wrestled with them for a century. For decades we've assumed these rules are probabilistic, that electrons jump unpredictably, photons choose paths by chance, and the universe itself hums to randomness. But consider this: every time a smartphone works, a GPS pinpoints your location, or a laser reads a barcode, something incredibly precise happens. Quantum randomness alone cannot explain this level of exactness. Something deeper, something more structured is at play. Now imagine a foggy morning. You're walking through mist, barely seeing a few feet ahead. You toss a pebble forward. Where it lands seems unpredictable, like nature is capricious. But then someone hands you a flashlight and illuminates the path. Suddenly, you see that the pebble is guided by currents of wind, subtle slopes in the terrain, hidden streams beneath the fog. It wasn't purely random, it was only unpredictable until you had the right information. Quantum mechanics may be like that fog. What we see as randomness could actually be the effect of hidden variables, rules, or structures we haven't yet understood. And that is exactly what a recent line of Nobel-winning research suggests. Beneath the apparent chaos, the universe is astonishingly ordered. Let's go deeper. Think about the double-slit experiment. A beam of electrons is fired at a screen through two slits. Alone, each electron seems to choose a path at random. Yet, when enough electrons accumulate, a pattern emerges, a pattern that hints at wave-like interference. It's as if each particle knows the structure of the entire system before it acts. How could something so small be aware of its context? Is it random, or is it following a hidden script? Now picture this: a vast orchestra, playing an intricate symphony. Each musician follows a precise score, yet every note seems spontaneous. From a distance, it might feel chaotic, like 1,000 unpredictable sounds. Up close, you see the structure, the score, the timing, the hidden order. Perhaps quantum particles are like those musicians, obeying a deeper score that our instruments have only begun to detect. And think about something else we all experience: intuition, a flash of insight, a sudden solution to a problem, a sense that things fit together. Could our minds, in some mysterious way, be tuned to detect patterns that are invisible at first glance, just as we now realize the universe itself might be? Now let's step into something poetic. Imagine a vast tapestry stretching infinitely in every direction. Each thread seems randomly placed, colors clashing, patterns invisible. But when viewed from the right distance, from a broader perspective, a breathtaking image emerges. That's what modern physics is beginning to reveal. The microscopic world may appear random, but at a deeper level, an intricate, interconnected pattern exists. Pause and reflect. What does this mean for our understanding of reality? If quantum mechanics is not random, then perhaps unpredictability is not a fundamental property of nature. Perhaps the universe is not a dice game, but a masterfully orchestrated dance of information, probability, and subtle rules that we are only starting to uncover. Let's zoom in even closer. Imagine the energy of a single electron. It fluctuates, interacts, and seems to hop between states unpredictably. But in reality, these fluctuations may obey hidden symmetries or constraints, rules encoded in the very fabric of reality. Like a magician's trick, what seems chaotic is actually guided by a hidden hand. Now consider what this could mean for technology. Quantum computers, lasers, MRI machines, and modern electronics rely on quantum principles. And yet these devices work with astonishing precision. Could we really build such instruments if the universe were fundamentally random? It seems unlikely. The very fact that we can engineer and predict outcomes at the quantum level hints that an underlying order exists. Let's use an analogy. Imagine flipping a coin, But instead of seeing heads or tails, the coin traces a path influenced by invisible winds, currents, and magnetic fields. To the casual observer, the flip seems random, but if you could measure every subtle force acting on it, the outcome could be predicted precisely. Quantum mechanics might be revealing something similar. What seems probabilistic may simply reflect our limited knowledge. Now step back and consider human history. For centuries, scientists accepted randomness as fundamental, even inevitable. The universe is inherently probabilistic, they said. Yet each new discovery, subtle correlations in particle behavior, unexpected symmetries, anomalies that refuse to be ignored, pushes us toward the idea that nature may be far more deterministic than we imagined. And here's the mind-expanding part. If quantum mechanics is not random, then our universe is profoundly intelligible. The patterns of matter, energy, and even consciousness might all obey deeper rules. The universe may not be a blind chaos, but a vast, coherent, interconnected web, waiting for minds like ours to discover it. Imagine standing at the edge of the cosmos, stars, galaxies, dark matter, all seemingly scattered at random. But what if each particle, each photon, each quantum fluctuation follows hidden threads weaving the structure of reality? What if the universe has a score, and we are only now beginning to hear the music? And think about the philosophical implications. Randomness suggests meaninglessness. Patterns suggest purpose. If the universe is guided by subtle laws, the cosmos itself may be intelligible, ordered, and perhaps even deeply elegant in ways we have yet to fully perceive. Pause and picture the tiniest particle dancing in a quantum field. It does not move chaotically. It moves in a rhythm dictated by rules hidden from casual observation, like a dancer guided by music we cannot yet hear. The particle follows the score of reality, not randomly, but with astonishing order. Now let's step back to everyday life. When you make decisions, when events unfold around you, you often assume randomness governs outcomes. But if the underlying universe is patterned, perhaps the world is far more intelligible than we assume. Perhaps chance is an illusion, a reflection of our limited perception, not a law of nature. And here comes the most profound question. If quantum mechanics is not random, then what does this say about reality itself? Could everything matter, energy, even life and consciousness, be guided by hidden structures we are only beginning to perceive? Could the universe be a coherent, intelligible whole, rather than a game of dice? Now imagine a vast cosmic tapestry again. Each thread, each quantum fluctuation, each particle is a stitch. From our limited perspective, it seems chaotic. But step back, observe closely, and suddenly you see patterns, symmetry, structure, connection, an astonishing invisible order that shapes every corner of existence. And finally, let's reflect on this. For decades, the world was told quantum mechanics is random. But perhaps that was a story of incomplete understanding. Hidden beneath the apparent unpredictability is an elegant, subtle order. The universe may not throw dice after all. It may follow a score so intricate, so vast, that we are only now glimpsing the music behind the particles. And as we reach the end of this first part, ask yourself what other patterns lie hidden in reality. What truths about the universe, consciousness, and existence are waiting to be discovered once we realize that randomness may be only a shadow of deeper order, that quantum mechanics, the very framework of reality, is not random, that beneath the apparent chaos there is hidden order, subtle patterns and rules that orchestrate the cosmos. Imagine standing beside a river. The water flows freely, rippling unpredictably on the surface. Yet beneath the surface, currents run deep, precise and consistent, guiding every drop along a hidden path. Quantum mechanics might be like that river. The surface seems chaotic, but underlying it there is structure, rhythm, and order we are only beginning to perceive. Think about the photons of light streaming into your room. Each particle behaves in ways that seem probabilistic, choosing paths that defy our intuition. Yet when you observe large numbers, beautiful patterns emerge, interference, diffraction, and correlations that suggest something is guiding them. What if this guiding principle is a fundamental law we haven't fully articulated yet? What if the randomness we see is simply a mask for a hidden structure? Consider entanglement, a phenomenon so strange that even Einstein called it spooky action at a distance. Two particles, separated across light years, behave in perfect correlation, instantaneously influencing each other. If their actions were truly random, such precise coordination would be impossible. Entanglement hints at a universe where everything is connected, a cosmos where information flows through invisible channels of order. Now picture a vast orchestra performing in total darkness. From a distance, the notes may sound scattered, chaotic, but if you could observe each musician closely, you would see the timing, the patterns, the subtle cues that create harmony. Quantum particles may be performing a similar symphony, guided by hidden rules, interacting in ways that appear random, yet ultimately part of a coherent composition. And let's not forget the observer effect. In quantum experiments, measurement seems to affect the outcome. But what does this really mean? It suggests that information, awareness, and interaction are fundamental, that the universe may not be a passive random stage, but a living responsive system, where patterns emerge in relation to observation. Could consciousness itself be entwined with this hidden order? Let's slow down and imagine a simple analogy. Imagine flipping a coin inside a room filled with tiny fans, each creating currents of air. To an outsider, the coin flip seems random, but with precise knowledge of every air current, every motion of the coin, every turbulence, the outcome could be predicted. Quantum mechanics may be similar. What we perceive as randomness could simply be the result of hidden variables, subtle influences we haven't yet measured. Now think about the implications. If the universe has hidden order at the quantum level, it may not be a chaotic accident. Instead, it may be intelligible, purposeful, and deeply coherent. From stars forming in galaxies to life arising on Earth, perhaps everything unfolds according to subtle, intricate rules we are only starting to glimpse. Imagine observing the growth of a tree. At first glance, it may seem random. Branches twist this way and that, leaves sprout in unpredictable directions. But step back and patterns emerge. Fibonacci spirals, symmetrical branching, optimization for sunlight. Nature, at first appearing chaotic, is guided by hidden rules. Quantum mechanics could be revealing something similar at the subatomic level. And consider technology. The very computers, smartphones, and lasers that define modern life rely on quantum principles. They operate with astonishing precision. If the universe were fundamentally random, such reliability would be impossible. The success of these technologies hints at a deep underlying structure, a blueprint encoded in reality itself. Let's take a poetic perspective. Picture the universe as an immense tapestry, each thread vibrating in space-time, each intersection a quantum event. On the surface, the threads seem scattered, chaotic, yet when observed from the right vantage, a breathtaking pattern emerges. Symmetry, coherence, hidden correlations. The universe may be far more orderly than the eye perceives. Pause and consider the philosophical ramifications. Randomness has always implied meaninglessness, but hidden order suggests intelligence, coherence, and elegance. Even if not conscious, the universe seems capable of self-organization at the tiniest scales. Could life, consciousness, and even human understanding itself be expressions of this underlying order? Now let's reflect on time. Quantum phenomena don't always obey our intuitive sense of past, present, and future. Events can be correlated in ways that seem to transcend linear time. If randomness is an illusion, perhaps time itself is woven into the patterns of hidden order, and what we perceive as chance is really a reflection of our limited perspective. Consider probability waves. Electrons exist not in fixed locations, but in clouds of potential, spread across space. Measurement collapses these potentials into definite outcomes. But what if the wave itself follows rules we have not yet uncovered? What if quantum uncertainty is not truly randomness, but a reflection of patterns that are subtle, multi-layered, and precise? Let's make it even more tangible. Imagine a massive audience doing the wave in a stadium. Each person stands or sits according to a local cue. To a distant observer, the wave looks chaotic at first glance. But zoom in and you see every action follows predictable rules. Local interactions create global patterns. Quantum events may be the same. What seems probabilistic is actually structured, emergent, and interconnected. Now think about human intuition again. Brilliant discoveries often arise from recognizing subtle patterns in chaos, the hidden order behind complexity. Could it be that nature itself operates similarly? Could our universe at the quantum level follow a hidden script waiting for minds like ours to detect it? And here comes a profound mental image. Imagine a vast, infinite library. Each book contains events, interactions, particles, and waves. At first, the pages seem scrambled, but when read carefully, patterns emerge, connections across space and time, a coherent narrative hidden beneath apparent randomness. Quantum mechanics may be that library, and we are only learning to read its code. Consider also the conservation of information. In physics, information cannot be destroyed. Black holes, once thought to obliterate all they consume, may in fact encode information in subtle ways, preserving correlations across the universe. If information persists, then the apparent randomness of quantum events might conceal a deeper, inviolable structure, a cosmic ledger of order. Pause and reflect on this. If hidden order exists, if quantum randomness is an illusion, then the universe is not a blind dice game. Every particle, every wave, every interaction could be part of a vast, coherent, interconnected pattern, the invisible architecture of reality itself. Imagine walking through a forest. Each leaf, each branch, seems arbitrary, scattered by wind and chance. But stand back, and symmetry emerges. Pathways form. Light filters through patterns of foliage. Ecosystems thrive in balanced harmony. Perhaps quantum mechanics is teaching us the same lesson. What looks random up close is part of a larger cosmic harmony. And here's the mind-bending thought. If the universe operates with hidden order at the quantum level, then perhaps everything, matter, energy, even consciousness, is guided by subtle principles we have yet to fully perceive. Perhaps life itself is an emergent property of this order, a reflection of the deep structure woven into reality. Finally, let's return to our opening image, the coin flip. What seemed random is now part of a larger understanding. The universe, in its tiniest details, may be patterned, intelligent, and coherent, far beyond what our senses reveal. Randomness, as we once thought, might simply be the fog obscuring the hidden music of reality. And as we conclude this part of the journey, ask yourself this: what other secrets of reality lie hidden, just beyond our perception? What structures, patterns, and harmonies shape the universe in ways we have yet to discover? And if randomness is only an illusion, how does that change the way we see ourselves, our lives, and the cosmos itself?